Hello people. I'm gonna show today. I'm gonna tell you about my project, which is scheduling using heuristic searches. And specific name of the project is timetable scheduling using genetic algorithm. Genetic algorithm is a heuristic search type of a heuristic search. So I'm gonna give you the introduction of the heuristic search in detail now. Heuristic searches are different from normal searches, normal algorithms, because they will not give you the optimal solution. They will always give you less optimal solution, but they will take comparatively less time to do that. So this is the slide for the genetic algorithm. Genetic algorithm consists of these parts. First is selection. We select the solution on which we are going to work by. We only select good solution, and to decide whether a solution is good or not, we use fitness function, which tell us about how fit the solution is. Then there are these two more processes about genetic algorithm. First is mutation. In mutation, we only change one or two things about the solution, and the new solution is slightly modified, not much, just slightly modified, one or two changes only, and we will see if it is better than the previous solution or not. If it is, we take it and delete the old one. Second is crossover. I'm giving you an example. Like there is a parent and children. We will do crossover and we will interchange these values. Like there is a crossover point. Suppose there is a crossover point at 2, which is like in 101, 0010, 101. This one is the crossover point. We will interchange the values from this point of these two solutions. They are called parents, and the new solutions will be called children. We will again calculate fitness through a fitness function. This will tell us if so this will help us to approach to the optimal solution as much as we can. Now I'm going to show you my code. Okay, before that I'll give you a introduction about the project, the specific project I did here. Suppose there is a list like this: batch, teacher, and subject. We have to allot them some classrooms, times, and day, so that this class can happen. So for that I'm going to use a 3D matrix. In this there is first, second, and third index represent the following. The first index represent number of days, second index represent number of time slots in a day, and third index represent number of rooms. So it is a 3D array. Now we are going to allocate these values to this 3D array. There are some constraints. You can see that hard constraints. One teacher cannot teach two classes at the same time. A group of students cannot attend two classes at one time. Two classes cannot be held in one room at the same time. A teacher cannot teach on more than maximum allotted hours. There cannot be any classes on holidays. Maximum number of hours allotted for a day cannot be exceeded. Hard constraints are the constraints that must be followed, so that we can. Without that, solution is not even valid. We won't even consider that. This is soft constraints. They are not necessary to follow, but it tells us about the quality of the solution, and only because of these soft constraints we tell if the solution is good or not, because most of the solution follow hard constraint, but the quality depends on the soft constraints. This is the penalty chart, how we are going to penalize. Now I'm going to show you my code. This is the code, I'm running it. Just see here, do you want to enter the name of teacher? I said no. There is a list of teachers which are already there, and now these are list of batches and the subjects they are going to learn. So I entered the input. Now this is the output, the solutions. We can start looking here. The best timetable according to this, as we can see, is 0. 0 means Monday. This is the optimal timetable. I'll show you in an Excel sheet. But after that, this is the main part. Best timetable, we got the best timetable. Then we are going to apply mutation on it. Now I have applied 10 mutations. As we can see, mutation was successful, and now heuristic value is 6600. Earlier the heuristic fitness was 13120. So now it improved to 6600. So it is improvement of like 100%. It just decrease the value of the heuristic very in a large amount. Now we have applied tabu search for it to improve the solution. So it says tabu was successful and the heuristic value is 6150. Earlier it was 6650 and now it is 6150. Now this shows even tabu search helps. These two are combinedly tabu search and mutation. Mutation is part of genetic algorithm. They really helps to improve the solution. Now I'm going to show you all these values in the Excel sheet which we have copied. So now I'm going to show you all these values in the Excel sheet. This is the final timetable after mutation. This is the timetable we have generated after mutation. Total saturation was 6600. Mutation was successful. This time must be better than the heuristic than the final.xls. This is final.tabu. This further improved the solution. You can see here, this is the timetable it generated and this is the value. As you can see, there are rows which have all the values, all the slots filled, and others have none of them. This is because of the arrow algorithm which I have used, which chooses first fill the whole row, and then move on to next row. So okay, I hope you get it. Thank you.